Okay, students, see you again in the today's class. Today's class will be dealt under the topic of normal forms. So you might be wondering that what is this normal form? So again, because we are in the unit propositional calculus, it deals with only the operators. That is, as I have mentioned, the operators what we are dealing with this unit is only negation, disjunction, conjunction, conditional, biconditional. Right? So by using these connectives, these are the connectives very much we are familiar with in the digital electronics paper also. So with these connectives only we are doing normal forms. So normal forms, before we enter into that we should know certain terminologies. So I'll tell you each and every terminology before we enter into the principal disjunctive normal form and principal conjunctive normal form. The first point is that you should know what is an elementary product. So elementary product, what it means, product in the sense we have only the conjunction, right? Product in the sense we have only the conjunction. So elementary product is product of the variables and their negations, right? So elementary product is what? It is product of the variables and their negations. So in the sense, for example, listen here, I'll tell you. So elementary product. So elementary product, as what I have said, it is a product of the variables and their negations. Say for example, I can have product of, I may take two variables, right? Fine. So I can have product of the variables and their negations, and I have got here. So therefore it should be only conjunction, alright? So I may have it as P and Q. It is along with the negation also I can have it. P and negation P I can have. P and negation Q I can have. Sorry, P and negation Q I can have. Or even I can have it to be as negation P and Q. Nothing wrong. Or even I can have it to be as Q and negation Q. Fine. So these are the examples of elementary product. Now tell me what is an elementary product? It is the product of the variables and their negations. So always whenever it is an elementary product, now product means it is always a conjunction. So conjunction is you have an and symbol in between the variables and also their negations. So this is an example of the elementary product. Understood now all of you all? Okay, fine. So after understanding what is meant by elementary product, next we have the terminology as elementary sum. So elementary sum, how do we define that elementary sum? So here you have sum. Sum means it is what? It is only the disjunction. That is, it is sum of variables and their negations. What is elementary sum? It is sum of variables and their negations. Again, as what we have mentioned in the elementary product, instead of the conjunction, we will have here disjunction. That's a difference between these two terms. Okay, fine. So let us see the examples of that. So elementary sum is what? It is sum of variables and their negations. So example, it is P or Q. I can have P or negation P. I can also have P or negation Q. Still I can have negation P or Q, and also I can have Q or negation Q. So look at this example now. So you have sum means it is disjunction, and we have said that it is a sum of variables and their negations. So variables and their negations are here. So these are some of the examples of elementary sum. Now I hope you will be very thorough with the terminology elementary product and elementary sum. I'll recall it. What is elementary product? It is a product of the variables and their negations. What is elementary sum? It is sum of the variables and their negations. So please register these two terminologies in your mind, and only then we will be able to find out what is our PCNF and PDNF. Even before going into that PCNF and PDNF, we must be familiar with the term called as disjunctive normal form. So in short, we write it as DNF. So disjunctive normal form or DNF, how we will define it? So what the definition says is that a compound proposition which consists of a sum of the elementary products and which is equivalent to a given proposition is called disjunctive normal form. Understand? So it is a compound proposition which consists of sum of the elementary products and which is equivalent to the given proposition is called the disjunctive normal form. So you must be very careful with all the terminologies inserted into the definition. So what it says is that disjunctive normal form, it is the compound proposition wherein it consists of sum of the elementary products. We know what is an elementary product, right? And also sum is nothing else but the disjunction. So can you give me an example of this compound proposition which consists of sum of the elementary product? Elementary product we have here, right? Say for example, elementary product I can take as these are my elementary products. Say for example, these are my elementary products. So, and it says that it is sum of the elementary products. Sum in this case, it is only the disjunction. So, this is an example of a disjunctive normal form. So, whatever proposition is given to us, and if we are supposed to find the disjunctive normal form, we will have to take only the sum of the elementary products, right? Understood? Okay, next, after understanding the concept of disjunctive normal form, we have the conjunctive normal form. So, what does that statement say? So, conjunctive normal form, what is the main connective here? Fine, that is and. Since because we have conjunction, the operator is and here. So, what does this convey? Conjunctive normal form, it is also a compound proposition which consists of product of elementary sums. Right? Why do I say it is product? Since because we are going to define the conjunctive normal form. Conjunctive is, the connective is and. So, whenever we have the connective is and, the terminology should be product. So, that is why it says that it is a compound proposition which consists of product of elementary sums and it is equivalent to a given proposition. Now, look at here. That is conjunctive normal form, CNF in short we write it. It is a compound proposition which consists of a product of elementary sums and which is equivalent to a given proposition. Now look at the previous terminologies. We know what is an elementary sum. So list out few of the elementary sums. We have P or Q, we have P or negation P, we have negation P or Q, and so on. So these are all the elementary sums, and what this says, it is the product. Product in the sense it is only and. So this is an example of a conjunctive normal form, right? So whatever statement is given to us, if we are in need of finding out the conjunctive normal form, always we should keep in mind that it is only the product of elementary sums. Fine? Okay. Now coming on to min term and max term. See, before getting enter into the principal disjunctive normal form and principal conjunctive normal form, we must be very much thorough with these terminologies, right? So now next we have min term. So what is meant by that min term? Suppose in case given a number of propositions or a variables, right? So given a number of variables, the products in which each variable or its negation but not both occurs only once is called min term, right? I repeat it now for you for your better understanding. What is meant by min term? We will be given with a number of logical variables. So with those logical variables, how do we get the min term? The min term is nothing else but the product in which all the variables or in which each variables or its negations but not both occurs only once. We call it to be as a min term, right? So what is this product of each variable or its negation? What do they mean? So they mean that if I have the variable as P, I should not have the conjunction of negation P along with my P term. Right? So either I should have only the variable P or I should have the variable only as negation P, but I should not have these both together. That is what it means here. So let me give you an example. So what does this min term says? Given a number of variables, the products in which each variable or its negation, see here you have or its negations but not both, occurs only once. So products in which each variable, right? So products now, what do we have? Min term as, I'll have it to be as See here, product, it is P and Q I'll have. But I cannot have this P and negation P. That is what it means. Minterm means in which each variable or its negation but not both. So I cannot have this term here. Instead I can have this term, P and negation Q. So negation Q is a separate variable, P is another separate variable. I can have the conjunction of these two. So that can be permitted. And next I can have negation P and Q. So this is also a minterm. But whereas I cannot have this Q and negation Q. So Q and its negation is together. So that should not be appearing in my minterm. So now what does this minterm says? So given a number of logical variables, this minterm defines that the product in which each variable or its negations but not both occurs only once is called as minterm. Now understood the difference between the elementary product and the minterm. So what's the difference we see between the elementary product and the minterm? In our elementary product, we can have the variable as well along with its negation part. Whereas in case of our minterm, we cannot have a variable along with its own negation of the variable. That is not permitted here. So that's the only difference between the elementary product and the minterm. Right? So this is the difference between the elementary product and minterm. And next we will see what is a max term. So max term, again, given a number of variables, right? So you may be given with n number of variables. Given a number of variables, sums in which each variable or its negation. So max term represents your disjunction. Sum in which each variable or its negation but not both occurs only once is called as the max term. So if you would have understood the terminology of minterm, this is very, very simple. Now you can just tell me the difference between what is elementary sum and this max term. So in our elementary sum, we will have a variable along with its negation of the same variable. But whereas in case of the max term, that is not permitted. That's the only difference between the elementary sum and the max term. So listen here now, I'll give you an example for your better understanding. So the example is, look at this elementary sum. Yes, fine, I can have here P or Q, that is the max term. I don't have P or its negation here. And P or negation P I cannot have. The variable is P and the negation. So what it says, but not both occurs. So therefore this is not permitted, but whereas this is permitted. P or negation Q is permitted. This is also permitted, negation P or Q. But whereas in case Q or negation Q is not permitted, since because this is contradicting the definition of the max term. Right? So now understood these four terminologies, right? So what is an elementary product? What is an elementary sum? What is the disjunctive normal form? What is meant by the conjunctive normal form? What is a minterm? What is a max term? So these are all the 6 terminologies one should be aware before we enter into principal disjunctive normal form and principal conjunctive normal form. So I'll just give you the comparison of elementary product and the minterm again. Right? So what's the difference between the elementary product and the minterm? So in the elementary product, we will be having product of the variables and its negations also is permitted. Whereas here, product of the variables or its negations, that is, it will not occur both. So both should not occur at a time. So that is excluded here. So that's the difference between the elementary product and the minterm. Now again, what's the difference between the elementary sum and the max term? So elementary sum is sum of the variables and its negations. So you can even have a variable along with its negation, and you can have the disjunction operator in between that. That is permitted there in the elementary sum. Whereas in case of the max term, this is not allowed. So why it is not allowed? You cannot have the variable along with the negation with the connective as or, that is disjunction. That is strictly prohibited here. So that's the difference between the elementary sum term and the max term. So now what is meant by disjunctive normal form? So disjunctive normal form is nothing else but the compound proposition, right? Whatever may be the statement, compound proposition, yesterday we have told in that class, that is, if you can break down the compound into a further simpler thing, it is called as the compound proposition. The compound proposition which consists of sum of the elementary products and which is equivalent to the given statement or the proposition, it is said to be the disjunctive normal form. So whenever you get the disjunctive normal form, the main connective you should have it as or. That is the disjunction. And next is conjunctive normal form. So conjunctive normal form, conjunction, what is the main connective? And. So that should be there. That is a compound proposition which consists of product of what? Elementary sums. So, and which is equivalent to the given proposition. So now I hope you will be very much thorough with these terminologies, and now we will enter into the normal forms. So normal forms, it is classified into two. One is called as the principal disjunctive normal form. The other one is called as the principal conjunctive normal form. Now look at this. What is principal disjunctive normal form? So in short, we write it to be as PDNF. A formula consisting of disjunction of min terms in the variables only and is equivalent to a given formula. That is a formula consisting of disjunction of min terms. We know what is a min term, right? And you will have to take only the disjunction, since because we are in need of finding out, or we are in need of defining what is principal disjunctive normal form. It is disjunction of the min terms in the variables only and is equivalent to a given formula. So what do you mean by a given formula? Suppose in case if you have three variables in the given statement, and in the same resultant principal disjunctive normal form. So each and every term should contain all the variables. That is what they mean here. And next is principal conjunctive normal form. So what is this principal conjunctive normal form says? A formula consisting of what? PCNF is what? The connective is conjunction. A formula consisting of conjunction of max terms in the variables only, and it is equivalent to the given proposition, is called the principal conjunctive normal form. So this is by using the logical laws and implications, we will be obtaining either a principal disjunctive normal form for the given problem or the principal conjunctive normal form for the given problem. Right. So this principal disjunctive and principal conjunctive normal forms are complementary to each other. That is complementary in the sense, if you negate PDNF, you will be able to get PCNF. If you negate PCNF, one will be able to get PDNF. That is what I mean here. And next, suppose even without using the laws of implication and equivalence, one can still find out the principal disjunctive normal form and principal conjunctive normal form. By what way? That is by construction of the truth table. So by using the truth table, still one can find out the principal disjunctive normal form and the principal conjunctive normal form. So that is as a note I will give you. So all these are very, very important, and which you will not find it in any of the materials. Even the textbooks or in the websites or YouTubes, you will not be able to find out such an elaborate manner of finding the normal forms. So please remember all these things. So now as a note I will give you. Whenever we are in using the truth table, how to find out the PDNF. So whatever statement is given to us, we will construct the truth table, right? So construction of the truth table in the sense, you will be looking into the last final column truth values. So there you will have either the truth value as T or the truth value as F. Right? So what is it called? Yesterday that also I have told you. Yes, fine, that is contingency, right? So whenever you have a contingency result, how to find out the PDNF? So the PDNF says that sum of the min terms, you know what is a min term now, right? Yes. So sum of the min terms whose truth value is T. So in the last final expression of the given proposition, you will have to look into the truth value. So when you look into the truth value, wherever you have the truth value as T, only for that you are supposed to take the min term. So those variables also should have the truth value as t. If some of the variable has the truth value as f, you can negate it and you can take it to be as t. Fine. So then from there you will take sum of, after finding out your minterms, you just sum it up and that will give you your PDNF. And next, PCNF, how to obtain it in case of our truth table. Suppose in case if you got your PDNF and if you take the negation of it, definitely you will get your PCNF. Suppose in case in the problem, if they didn't ask you to find out your PDNF, instead they ask only you to find out your PCNF, how do we find it? So for that, PCNF means whenever we use the truth table, it is sum of the minterms, the whole complement. So as I've said already, this PDNF and PCNF are complement to each other. So that is why there I said it as sum of the minterms, and here I say it as sum of the minterms, the whole complement. So sum of the minterms, the whole complement is what? It is only the max terms, right? So sum of the minterm, the whole complement, whose truth value, so there I have taken the truth value to be as t. Here I am taking the complement of that. So what should be the truth value? Yes, fine, that's right. So whose truth value should be f. So this is how we will be finding out the PDNF and PCNF by using the truth table, right? So keeping all this in mind, now we will do a problem and then we will be able to understand in a better way. I will teach you one problem. See here, obtain the principal conjunctive normal form of negation P conditional R and Q biconditional P, and hence obtain the PCNF. So now I'll give you the solution. So we'll approach the problem by two ways, right? First one, we'll do it by using the laws of equivalence and implication, and for the same problem we'll use the truth table and we'll check out whether we get the same result in both the cases. Fine? Yes. So now whatever may be the statement, I will take the entire statement to be as capital S. So this capital S doesn't mean that I have that to be as a variable here. I am representing the entire given proposition as yes. So I have it to be as negation P conditional R and Q biconditional P. So whatever statement or proposition is given, now I will represent that entire expression or the entire proposition to be as yes. And now, okay, I forgot to give you the procedure for finding out the PCNF and PDNF. So you should remember 3 points while deriving the PCNF and PDNF. So the first point, what it says is that whenever we have conditional or biconditional, right? Whenever we have what? Conditional or biconditional connective, it should be suitably replaced by negation, conjunction, or contradiction, or disjunction, right? So what is the first point says? If whenever we have conditional or biconditional statement in the given problem, we'll have to remove it by suitably replacing it by negation, conjunction and disjunction, right? And the second point is that if we have negation in front of the given proposition or in part of the front of the given proposition, we'll have to immediately apply De Morgan's law. Understood? So what does that second point say? So second point says that whenever we have negation in front of the given statement or the proposition, or even in the front of the part of the proposition, one has to apply immediately the De Morgan's law. So that is your second point. And what is the third point says? If necessary, one can apply idempotent law, associative, or even the distributive law. So these are the 3 points one has to keep in mind while deriving the PDNF or PCNF. Let me repeat it for your better understanding. The first point says that whenever we have conditional connective and biconditional connective, that has to be suitably replaced by negation, conjunction or disjunction. That should be our first intention. And the second point says that whenever we have negation in front of the proposition or in front of the part of the proposition, De Morgan's law should be immediately applied. Then what does the third point say? if needed or if necessary, one has to apply absorption law, distributive law, or even you can apply the commutative property and associative. So these are the three things one has to keep in mind before deriving the PCNF or PDNF. Now coming on to this problem, look at now. So here what does the first point says? First point say I will have to remove my conditional and biconditional suitably by replacing negation, conjunction and disjunction. See here, I can apply here what law? I can apply conditional equivalence. So then what do I get? I get it as P disjunction R. And this says that I can have Q, since this is a two-sided arrow, this is if and only if condition, both the ways it is permitted. I can even write this. And next is P disjunction R, and again I can apply the condition. I will have to remove this conditional and biconditional, right? So if I want to remove, I will have to apply the conditional equivalence. So that is negation Q or P and negation P or Q. Understood? So now what I have done is that first point I have applied, that is I have removed my conditional and biconditional connective suitably by replacing it by negation or and. So these are the points I have to keep in mind. That is the first point of deriving my PDNF or PCNF. So this is equivalent to. Now we are in need of finding out PCNF. What is PCNF? So PCNF says that it is conjunction of the max terms, right? Conjunction of the max terms. So conjunction of the max terms na, your main connective must be and in between you should have or, right? So main connective is and here, fine, that is good, fine. So this is main connective is and here within the parenthesis I have or, fine. This is conjunctive normal form, but it is not principal conjunctive normal form. Why do I say that this is not principal conjunctive normal form? Because what does that statement says? So if it should be a principal conjunctive normal form, it is conjunction of the max terms in the variables, and that should be equivalent to the given proposition. Equivalent to the given proposition in the sense, what it means is that, so first in the given proposition, I will have to see to that how many variables are present. So totally here how many variables are present? 3 variables, P, Q, R. 3 variables are present, and now it is not the exact form of a given proposition. So some of the variable is missing here, so it is not the exact form of a PCNF. So still I will have to do some calculations and then I will have to get my exact PCNF. So look at this now. So here in this parenthesis, what is the variable that is missing? I have got 3 variables, so Q is missing. So in this which is missing, R is missing. Again in this which is missing, R is missing. So therefore, I will have to insert these missed out variables into each and every term in such a way that when I insert those variables, the original value of that term should not be changed or it should not be altered. Understood? So whenever I insert the missed out term, while inserting it, the original value of the term should not be altered, right? So look at that point and in such a way that you will have to insert it. So here what is missing? Q is missing. See here how I am inserting. This is a very, very important point. You have to be very careful. So how do I insert Q here? So that is, I can have Q, negation Q. So I am first in need of finding out my PCNF. So C stands for conjunction. So whenever I insert a variable, the suitable connective of this conjunction and must be added, right? So Q and negation Q, and then I can have it to be as or, right? So PCNF, whatever variable is missed out, while inserting that variable, I should have the suitable connective. Then the other connective can be added over here. So now look at this now. So what do we get? Q and negation Q. So Q and negation Q, what is it? It is F. So F value is only 0, right? 0 plus anything will give you that value. So therefore this is not changed. This is not altered. Fine. So in a similar manner, I will have to do. So this is negation Q or P I have. Now, what is the missed out variable? R is the missed out variable. How do I insert that R? It is R and negation R. Now, I have to see that what connective I can use. Now, I am in need of what? It is conjunction. So, the connective should be and here I can have the disjunction operator. Again, in a similar manner, I can have negation P or Q. You will have to tell me now. Tell me, students. So, here what is missed out? R is missed out. So, we will be inserting our R with its negation term. So, what should be the connective used here? Since because we are in need of finding out the principal conjunctive normal form, the main connective is what? And. So, you will be inserting that. So, this is what. So, again, now everything is fine. You will have to third step what it says. If needed, distributive, associative or absorption law can be applied. So, now can we apply the distributive law here? See to that. It is, we will write it in order. It is P or Q or R and it is P or negation Q or R. I have applied the distributive law here. And again here you look at this, we can write it in order, that is P or negation Q or R and P or negation Q or negation R and I will have negation P or Q or R and negation P or Q or negation R. So, now look at this now. Final result, we are in need of finding out the PCNF, that is the main connective must be what? The main connective should be and in between you can have R. The definition of principal conjunctive normal form says what? A formula consisting of conjunction of max terms in the variables only and is equivalent to a given formula. So, conjunction of the max term, conjunction of the max term, conjunction of the max term, everywhere we have that only. So, max term now you should have the connective as R. Conjunction is and, everywhere we have only the max terms. And one more point you will have to see. So, if any of the term is repeated, you will have to take it only once. See here, PQR, I will have to check out whether PQR is present anywhere, nowhere. So, this is PQR and P negation QR, P negation QR, it is repeated. So, therefore, I will consider it only once, right? And then again P negation Q negation R. Is it repeated? No. So, then it is and P negation Q or negation R. Then I will have to check it out. This term, this is also not repeated. So, and negation P or Q or R and negation P or Q or negation R. So, totally how many terms I have got? 1, 2, 3, 4, 5. This is my required PCNF. Is required PCNF. Understood here? PCNF means it is the conjunction of the max terms and that is equivalent to the given proposition. So, you will have to look into each and every max term here whether it contains same number of variables as given in the statement. So, that is fine here. So, this is my S, entire S represents the entire PCNF. And now from this itself we can obtain the PDNF. Sorry, here it should be PDNF, PCNF and PDNF. So, from this itself we can obtain your PDNF. So, PDNF in the sense, what did I say? This PCNF and PDNF are complementary to each other. Fine. So, now I have got my S. With this, what I will do with that? So, I will find out what is this not of S. This not of S, I mean it should be the remaining min terms that does not appear in my S. Understood what is meant by the min terms? So, right. So, now remaining terms, this not R represents remaining terms not in S, right. So, this not S represents, this not S doesn't mean that I have to take the negation of the entire statement. This not S represents that the remaining terms that does not appear in my S. So, if I have 3 number of variables while constructing the truth table, how many number of rows will I have there? Yesterday that we have seen it. So it is, you should have 2 power n number of rows. So in this problem, we have got 3 variables as p, q, r. So totally how many rows or how many terms we'll have? We'll have 2 power 8. So sorry, 2 power 3. So 2 power 3 is what? It is 8 terms we should have. So but whereas we have got only 5 terms, so we'll have to write down those remaining 3 terms as denoted by negation of s. So what are all the 3 terms that has been missed out here? I will have to find it out. So not of all the 3 terms have been missed out. That is not P or not Q or not R. That is missed out. And next is P negation Q R. So not P, not Q R has been missed out. Yes. Not P, not Q R has been missed out. Not P, I don't find this not P, not Q, R. Not P, not Q, R, it is not present. Fine. And one more term is also missed out. I will have to find that term. So P, not Q, R. P, not P, Q, R. Not P, Q, R is here. Okay. Then P, not Q, R. P, not Q, R is also here. Here not P, Q, R. Not P, Q, R is there. So what is the other term which is missing out here? We'll have to find it now. So this is missing, and then not P I've got here. Okay. P, not Q, not R is there. P, not Q, R. Yes, it is missing. P, not Q, R. P, Q, not R, is it there? P, Q, not R is not there. P, Q, not R. Not R. So these are the 3 terms missing. P, Q, not R is missing. So this negation is what it represents. It is the remaining terms that is not present in S. Now I'll find out what is negation of negation is. That is equivalent to S, which is, for this I will have to take the negation. Negation of negation P or negation Q or negation R, and negation P or negation Q or R, and P or Q or negation R. So if I take the negation, so S is the original statement. For this statement I am finding out the PDNF. So if I take it, I will have to apply the De Morgan's law. Then it becomes P and Q and R. This and will become R, and this will become P and Q and not R. This will become R, not P and not Q and R. See now here, this is my PDNF, is required PDNF. What does that mean, PDNF? It is a formula consisting of disjunction of the minterms. I do have the minterms and it is the disjunction. So therefore this is my required PDNF for the given original term. Now understood how to obtain the PDNF and PCNF by using only the logical laws of implication and equivalence. Any doubt you have got here, I'll recall it again here for you. First point is that whenever we have conditional and biconditional statements, we will have to remove it by suitably replacing it by the connectives negation, conjunction and disjunction. Second point is that whenever we have negation in front of the proposition or in front of any part of the proposition, we will have to apply the De Morgan's law. And the third point says that if needed, we can apply suitably associative, distributive or idempotent or absorption, whatever law is needed for us, we can obtain it. So this is how we will be finding out the PCNF and PDNF for any given problem. And next, for the same problem, we will try to make use of the truth table and then we will find out the PCNF and PDNF, and we will have a cross check whether this gets along with the other method or not, right? We will see that now. Obtain the PCNF of negation P conditional R and Q biconditional P and hence obtain the PDNF using truth table, right? So this we will try to do it. So what we will do here is that we will try to construct the truth table for the given proposition, and then we will try to obtain the PCNF and PDNF. So first thing, we will have to see how many variables are used here in the statement. There are 3 variables. If I have 3 variables, then how many rows will I have in the truth table? It is 2 power 3. So that is 8 rows I will have. So it is P, Q, R I will have. So it is T, T, T. I can have 4 T's, 4 F's here, which will be easier for me. T, T, F, F, T, T, F, F. Here T, F, T, F, T, F, T, F. So I have got 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. So now I will have to construct the truth table for this. So I will have to first find out what is my not P. So not P in the sense I will have F, 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 F. Here I will have T, 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 T. Next is not P conditional R. So not P conditional R. So what it says, whenever I have not P, the truth value is T, and R truth value is F, the resultant will be F. I will have to look into that. So TF, no TT, TF. So TF na here I will have it to be as F. So TF I will have here to be as F. Right, understood? So elsewhere I will have only T. Right, T, 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 T and T. And next I will have to find Q biconditional P. So Q biconditional P in the sense, if I have the identical truth values for both P and Q, the truth value will be T. If not, it will be false. So PQ identical truth value, yes, I have T. I have here identical truth value, it is T. So I don't have here the identical truth value, so it is F. It is not identical, so it is F. So here again, here also it is not identical, then it is F. Not identical, it is F. And it is identical, it is T. Again identical, it is T. So again I will have to find out not P condition R and Q biconditional P. So this is conjunction. So what will be the truth value? If only I have the truth value of this term to be as T and this term to be as T, the resultant will be T. If not, elsewhere I will have only false. So now look at this. T and T I get T, T and T I get T, T and F I get only F, T and F I get F, T and F I get F, F and F, yes only F, T and T I get T, T and F I get F. Right? So this is my truth value for the entire expression. Then I will have to find out the min term. So how do I find out my min term? First let me find out the PDNF. So what does the PDNF say? So PDNF says that it is sum of the min term whose truth value is T. Whose truth value is T. So I will have to look into the last column truth value wherever I have got that value to be as T. So in that case, I have got only 3 terms, 3 T's I have, right? So for that only I am supposed to find out the min term. So let me find out the min term for these. So while finding out the min term also for each and every variable, I should have the truth value as T. If not, I don't have, in that case I will have to negate it and take. So it is everywhere P, Q, R is T. So I will take it as P and Q and R. Here also I have T. It is P and Q, and see here I have got the truth value as F, but then the truth value should be only T. So I can negate it. If I negate it, I will get T. So negate it now, I will have only negation R, right? And here see negation. So if I negate this, I will get T. In that case, it will be negation P. And if I negate this, again I will have negation Q. And here T only I have, it is and R. So these are only the three minterms I get it. So sum of the minterms, whose truth value? I have got the sum, yes. So now this is sum of the minterms. I will write the minterms, P and Q and R, then P and Q and not R, again not P and not Q and R. So now what does it say? It says that it is sum of the minterms. Sum in the sense, what should be the connective you will get into your mind? That is disjunction, sum. So this is my required PDNF, right? Understood? So required PDNF is this. And how do I get my PCNF? From here itself I can get it, na? So that is sum of the minterm, the whole complement, whose truth value is F. Sum of the minterm, the whole complement, whose truth value is F. So wherever I have F, right, I will have to take the minterms whole complement. So I have here 1, 2, 3, 4, 5 terms I have. So whose final truth value is F, and I will have to look into each and every variable, and for that variable I should have only the truth value as T. If don't, in that case I will take only the negation of that term. So it is P and this is not Q and R, and this is P and not Q and not R. This is not P and Q and R. And this is not P and Q and not R, and this is not P and not Q and not R. So these are the 5 minterms I have, and now I will have to sum up and take the complement of that. So summing in the sense, I will have the disjunction. So P and not Q and R, disjunction P and not Q and not R, disjunction not P and Q and R, disjunction not P and Q and not R, disjunction not P and not Q and not R. This, the whole complement I will have to take. Whole complement in the sense, I will have to apply the De Morgan's law. So this is, I will have not P, R, Q, R, negation R, and this becomes and not P, R, Q, or R. This becomes and this becomes P, R, not Q, R, not R, and here this becomes P, R, not Q, R, R, and P, R, Q, R, R. So this is my required PCNF. Now let us have the cross check with that of the loss and then with that of my truth table. This is my PDN. Where is my PDNF? Here I do have my PDNF. What is my PDNF? PQR or PQ negation R, no, not P, not Q, R. Yes, fine, that gets well. And next, what is my PCNF? PQR, where is it? PQR, P negation QR, P negation QR, yes, negation QR, P negation Q negation R, I have negation P QR, negation P Q negation R, yes. So both are one and the same. So this is how we will do our PCNF and PDNF by applying the logical laws of equivalence and implication as well that of the construction of truth table. Thank you.